Welcome to Statistics for Surveys, Session 2, Descriptive Statistics Tables, Segment 2, Ordinal Variables, where we'll discuss cumulative frequencies and cumulative relative frequencies. The objective of this segment is to understand how to determine, but also interpret cumulative frequencies. You would need to be familiar with the terms absolute frequency and relative frequency from the previous segment, and in this segment we'll discuss cumulative frequency and cumulative relative frequency. To explain cumulative frequencies, let's have a look at the table below. We see that a teacher has actually classified the students based on their grade from very poor to very good, which is an ordinal scale. One of the questions we might have is how many students failed the test? This is actually the same looking at these values as asking how many students scored a just fail or worse, which is simply the addition of these three categories, because these three categories all indicate that a student failed. In this case, this becomes 5 plus 10 plus 4 equals 19. A fancy word for adding up is to accumulate, hence the name cumulative frequency. This 19 is indeed the cumulative frequency of the just fail category. The interpretation is of course that this means that 19 students scored a just fail or worse. We can do this for each category. For the first one, it's simply the number of students who scored very poor or worse, which is the 5 that scored very poor. For the next one, we'll have a look at how many students scored poor or worse, which is the addition of these two, which becomes 15. For the number of students who scored a just pass or worse, we add up all of these. And for the number of students who scored a pass or worse, we add up almost all of them. And the last one is actually everybody, because everybody scored very good or worse. As you might have noticed, there's another way of calculating cumulative frequencies. The first one is always the same as the absolute frequency of the first one. The next one will actually now use the previous cumulative frequency, but because that's the same as the first group again, and there's not much difference. It's when we get to the just fail cumulative frequency, you might notice that the 5 plus 10 here is also actually in here. So that 15 that we already calculated, we can reuse and simply add those 4 again to get the 19. And we can do the same for the other ones. The 5 plus 10 plus 4 from the just fail, we also see again here. So the next one, we can simply use that 19 again and do 19 plus the 15 to get 34 again. For the next one, we can use, as you can see in the calculation, we used all of it again, and we get now therefore 34 plus 12 equals 46. And for the last one, 46 plus 4 equals 50. So this is much shorter and quicker to actually calculate the cumulative frequencies. The results in the end are of course the same. Instead of adding up the absolute frequencies, we can also keep on adding up the relative frequencies and then create the cumulative relative frequency. One approach is to indeed keep on adding up the relative frequencies to do this. However, due to rounding errors, this sometimes then also accumulate all those rounding errors in the relative frequency. It's therefore preferred to do it not based on the relative frequency, but to actually calculate the cumulative relative frequency by another way, which is using the cumulative frequency in itself and then divide those by the total number of cases, in this case 50. The results in this case are the same because there was no rounding done at the relative frequency, but in general it's preferred to use the cumulative frequency and divide that by the total to get the cumulative relative frequency. If we go one way from cumulative frequency to cumulative relative frequency, then of course we can also simply divide by 100 and then multiply by the total to get the cumulative frequency. So for example, we could use the 34 if we wanted to calculate this one based on 68%. So then we would use 68 divided by 100 and then times the total, which was 50. So times 50, and that would give you the 34. If we are given cumulative frequencies instead of absolute frequencies, we can still convert these back to the absolute frequencies. For example, if we wanted to know how many students scored a just pass, we can have a look at the cumulative frequency and therefore know that 34 students scored a just pass or worse. We also see that 19 students had a just fail or worse. So the difference between these two should be the number of students who had exactly a just pass, which turns out to be 34 minus 19 equals 15 students, which is the absolute frequency. You can do the similar calculations for all the other values as well. One more type of question sometimes pops up on exams about cumulative frequencies. If we are given the cumulative frequencies, how many students scored a pass? We can either convert everything back to absolute frequencies. There's another way to approach this. We can see that 50 students was the total number of students because that's the cumulative frequency of the last value. We also notice that 19 students had a fail, or a poor or very poor, but at least failed the exam. So the difference between those two must be the number of students that passed, which turns out to be 50 minus 19 equals 31. On this slide, a table with all the discussed frequencies so far. We can see immediately that 4 students, for example, had a just fail, that accounts for 8% of the students. 19 students had a just fail or worse, and 38% of the students had a just fail or worse. Please note that the interpretation of the cumulative depends on how these are actually organized. In this case, it ranges from poor to very good, while we could have also done it actually the other way around, from very good to very poor. There's an alternative type of frequency that's connected to this, known as inverse cumulative frequencies, but I'll leave those for an optional segment. The cumulative frequency is normally added if you have an ordinal variable. At a nominal variable, for example fruit, you can still calculate cumulative frequencies, just as we did with the ordinal variable, but the interpretation is a little bit strange or actually not possible. For example, the cumulative frequency of 19 would now mean that 19 people eat a melon or less. And although this is in alphabetical order, it's a little bit strange to say 19 people eat melons or less. So therefore, at a nominal variable, cumulative frequencies are usually not added.